All right, so this talk starts somewhat predictably about 3,500 years ago. It starts with something known as the cardiocentric theory. The cardiocentric theory was the belief popularized by the ancient Egyptians that the heart was the single most important organ in the human body. They believed the heart to be so important that it controlled thought and feeling, emotion, intelligence. They thought it was the seat of the human being. They thought it was so important that when people died, all of their organs would be removed and embalmed and put in these jars, except the heart, which was left in the sort of chest cavity. So when the dead passed on to the afterlife, they would meet up with the god of death, Anubis, who would weigh their heart against a feather. And if the heart was lighter than a feather, they would pass through to ancient Egyptian afterlife. If the heart was heavier than a feather, they would go and meet what was genuinely translated to the devourer, which is a pretty gnarly ancient Egyptian concept. I feel very, very sorry for ancient Egyptians. I don't know how much a heart actually weighs, but I'm pretty sure they all weigh more than a feather. And when you consider that one's also in a clay pot, ancient Egyptian heaven must have been a very empty place. This belief lasted for thousands and thousands and thousands of years. People genuinely believed the heart to be the single most organ in the human body. And of course, there's no such thing as a single most important organ. They all need to work together. But it wasn't for another 1,000 years that somebody even suggested the brain might be important. Hippocrates came up with what he called the cephalocentric theory, and ceph, the sort of prefix, means of the head. He suggested this around 1,000 years later. No one listened to him. People just didn't take it seriously. It wasn't really considered a viable alternative, so people continued with the cardiocentric theory. It wasn't until this guy, William Harvey, in the 15 to 1600s, actually just sort of proved that the brain is really important. But what was kind of ironic is he didn't prove the brain was important, he just proved that he could work out what the heart did do, therefore the other organs must be responsible for other stuff. It took thousands and thousands of years for us to finally realize just how important the brain or the head is. See what I did there? It's pretty smart, isn't it? This is going to be a talk all about head tags, because I see something genuinely very, very similar in my day-to-day work as a performance consultant. The head tag is the one part of the website that certainly, hopefully, a user will never, ever see. Most developers don't see it until we're actually coding, right? But no one ever sees the head tags. We've got a real over-focus on what happens in the body, often overlooking what happens up top. I am obsessed with head tags. In this talk, I'm going to teach you way more than you ever want. I promise you, way more than you ever wanted to know about head tags. The importance of them, how to optimize them, how to make sure they're running nice and fast and stable, and ensuring that the rest of the page behaves accordingly. This is a slightly abridged version of this talk, a slightly shorter version. I'll put a link to the full slides, but I just want to go through two key concepts really quickly that I just want you to memorize while we go through the slides, just so that everything continues to make sense. And the next slide may be patronizing to a lot of you. I don't intend it to be, but it's just really important to have these two concepts in mind as we discuss the rest of the talk. HTML is parsed line by line. It's synchronous. The browser doesn't even know line 4 exists until it's finished dealing with line 3. And of course, lines are a bit of a human construct. HTML is parsed line by line. There is no control flow, there is no logic. You can't pass information back up the DOM tree. HTML is parsed line by line. This is what makes HTML very reliable and very fast. This is a feature, right? This is not a bug. This is why we like HTML. So HTML is parsed line by line. That's a concept that will keep reoccurring throughout the talk. And the second bit is the head is the single biggest render blocking part of your document. Because HTML is parsed line by line, and a user doesn't see anything until you get to the body tags, that means that the head must be render blocking. If the body is the first visible part of the page, and HTML has to be parsed line by line, you can just reason that the head must be render blocking. We can't render the opening body tag until we've parsed the closing head tag. Therefore, anything synchronous inside your head, and indeed the head itself, is entirely render blocking. If you ever want to optimize first paint, start with your head tags. So those are the two key concepts I want you to keep in mind as we go through this talk. And what this talk is going to do, it's going to take a really bad set of head tags. I've designed the ultimate worst experience, which is a waste of time because most of my clients have done this already. I don't know why I did it again. What I've done is I've got this baseline. You can go and see that. There's a GitHub repo there. What we're going to do is start with a genuine mixture of real things that I've seen on client projects, slowly refactor these head tags to be much, much faster. Get your phones handy. You might want to take a picture of this next slide, just so you can look at it while I'm sort of talking. These are the head tags in question. I fear that this may be a little small. Apologies for anyone near the back. That is probably a little small. But this, what is it? We've got like 40-some lines, 42 lines of HTML there. What I want you to do is look through and just see if you can spot anything erroneous, spot anything weird, spot any anti-patterns. The stuff in here is fairly pedestrian. This is stuff that I've seen on client projects time and time and time again. There's nothing really, really obvious in here. I mean, yeah, there's this really slow bit of JavaScript, but we've got content security policies, we've got cross-site request forgery tokens, we've got some imports, we've got inline.js, we've got async.js. We've got a bunch of different stuff, but all I can, basically the thing I want to stress here, everything on this slide I have encountered in a client project at some point. None of this is crazy, outrageous stuff that never existed before. This is a slide that is full of real examples that I've optimized on real client projects. If we run this head tag, this 42 lines of HTML, through a web page test, if you're not familiar with web page test, this graph here, what I want you to do, if you haven't seen one of these before, is imagine taking this graph and putting it vertical, and it's Tetris. The idea is to get these packed up as tightly as possible. We want to get it packed up as tightly as possible that way, but if you flip it on its side, just think of it as Tetris. What we're going to do is, throughout this talk, instead of it being this wide, we're going to get it down, 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 and try to get it as tightly packed as possible. What we want is this to be nice and narrow, which means it's going to be faster. So any performance-oriented people in the room are probably already looking at this and thinking, geez, that is bad. Like, that's really bad. For just a few lines of HTML, there's a lot going on here. This is like the perfect storm. What we're going to do together is step through this, this demo, this head tag sort of example, and refactor it together, make it all a lot faster. What we aren't going to do is refactor like the code base itself. We're not going to re-platform anything. We're not going to rewrite any code. All we're going to do is move some lines of HTML around, just swap a few things around, and get this a lot faster. As it stands right now, first paint, or first contentful paint for this particular waterfall, these head tags, comes in at a staggering 9.3 seconds. It took 9.3 seconds to render this page. It's a long time. Anyone who worked in the performance space, we tend to discuss things in milliseconds. If you're discussing things in the realm of seconds, it's bad news. So discussing something in the realm of 9 seconds is like, it's like prehistoric, right? It's might as well be looking at ancient history there. So, some advice is first, don't be so big-headed. A lot of the time I see things crammed into the head tags that simply don't need to be there. If you can get rid of it, get it out of there. This could be a multitude of different things. It could be inefficiencies in your head tags. So we already had one on the previous slide, but it could be like a redirect in the head. We'll discuss that one in a second. CSS. CSS blocks rendering, but a change to all modern browsers, except Safari, which probably isn't a modern browser anymore. You can put CSS in your body tags, makes pages way faster. So if the CSS doesn't need to block rendering of the entire page, move it out of the head. Certain third-party scripts don't need to run immediately. Put them near the closing body tag. So there's loads of inefficiencies, loads of stuff we could probably move out of the head to make them physically smaller, fewer lines of code. One thing we did have is we had a redirect straight in the head tags. This is a really inopportune place to incur a redirect. And a bunch of you are probably thinking, Harry, come on, no one's going to do that. No one's that stupid. No one's going to put a redirect in their head tags that's like day one, like what you learn on day one as a performance engineer. It happens way more often than you would think. Right here, we're losing 492 milliseconds just getting sent to a different domain. 492 milliseconds may not sound like a lot, but I worked with a client in the UK a few years ago. We worked out if we could save them 300 milliseconds, they would make an extra £8 million a year. So finding 492 for the sake of one redirect, that's pretty good news. Anyone who's self-employed or thinking of going self-employed, by the way, whenever you send a client an invoice, never tell them what you did. I can't say, oh, I removed a redirect, you owe me 10 grand. What you do is you tell them the outcome of what you did. Well, I sped your site up by half a second. Give me 10 grand. But yeah, this is trivial work. What we're about to look at throughout this talk is not complex stuff. It's simple, trivial changes. But for the right businesses, this has a huge, huge impact. The reason you start to see redirects in the head is usually something as simple as this. This is something I saw on a genuine client site. You might always want to point at latest jQuery. Unpackage is a way of doing this. We shouldn't do this anyway. Always self-host your static asset. We'll come back to that. But we're just pointing at like a, it's not proper Semver, is it? It's at latest, which is going to get redirected to a versioned file. This is a redirect straight in the head tags. Avoid it. Get rid of it. And you'll see the before and after. We've now gone from 13 entries to 12 entries. We got rid of a redirect. Here's where I've got to make my first confession. Performance testing is very non-deterministic, and you could reload the same page 5 times and get 5 very different results. I've been very honest with my data. I've been very honest with my numbers. So I've not massaged the figures. I've used whatever data the tests have given me. You can see at the top we're losing 492 milliseconds. When I reran the test, getting rid of that, we actually only got 0.041 seconds faster. Technically, it should have been around 500 milliseconds, but the median of 5 tests before and after, the savings are actually only about 41 milliseconds, which is kind of a bit underwhelming. However, I would still always recommend removing these redirects, because at least we're in the green. That redirect was pointing to unpackage. That in itself is a problem. We shouldn't do that. So self-host whatever you can. This talk, like I said, is a slightly shorter version, so I can't go into the details. So basically, you've just got to trust me. But if you want to read exactly why you should self-host things, don't leave, especially static assets, don't leave them on anybody else's infrastructure. Don't point to other domains. We're losing time getting there. We're susceptible to outages. There are loads of risks involved with hosting your files elsewhere. So don't use code.jQuery. Don't use CDN.js. Don't use any of those services that realistically should not exist anymore. If you care about performance and reliability, and to an extent security, self-host everything. By doing that, we begin to trim away at the network overhead, the network negotiation. There are other performance benefits to self-hosting, but they are less obvious from this perspective. The most obvious benefit from these charts is going to be losing that time there. That's time spent looking for different IP addresses, different origins. We can save that time quite trivially. And what's quite nice is this had a pretty big impact. This saved us 377 milliseconds just by self-hosting a few files. What's interesting about this is, remember that 300 milliseconds I talked about? We're now already at 418 just for 2 simple changes regarding static files. Definitely worth doing. The next thing's quite interesting. Go and get your head checked out. Invalid head tags, they don't happen that often, but you can quite trivially, accidentally invalidate your head tags. When was the last time, well, that's not really a yes or no question, is it? Has anybody run the HTML validator in the last 12 months? Wow. Well, I think you're either showing off or lying. I didn't know people did that anymore. Wow. OK, who used a spacer GIF in the last 5 years? I actually did. I was not expecting that many hands. Go you. I actually have run HTML through the validator like in the last 12 months, not because I care about valid HTML. Well, I don't not care about it. It just helps me find one specific potential bug. Invalid head tags can cause problems. We've got a thing on this slide here. We've got something that's going to cause an HTML parsing error. And that's this. And for those, apologies for anyone a bit further back, this text is a bit small. We've got a cross-site request forgery token in a hidden input, which is a very common way of doing it. A lot of frameworks just stick this in the head tags. And the problem is, there is a fixed, sort of hard-coded list of elements that are allowed in the head. Any element that is illegal, any element that isn't allowed in the head tags is going to cause a syntax error. And what will happen is the browser panics. HTML is parsed line by line, right? And if a browser is in the head tags, but encounters an invalid element that's not allowed in the head, it panics and thinks, shit, I should be in the body now. And on the fly, the browser's going to do this. It's going to, on the fly, it's going to close the head tags, open a body tag, and start putting the valid HTML in the new body. This is the really good example of the difference between DOM and HTML. This is your DOM. And what you'll see now is underneath that input, we've got script, style, we've got meta, we've got another script. All of those head elements have now been pushed into the body. They're still in the correct order, and because HTML is parsed line by line, yes. Things are still going to run in the correct order, but there are some implications with having this stuff in the body. So if we look at this, we fixed the head tags. We got rid of we had an erroneous request. We got a double request here. So we've gone from 12 entries down to 11. Fixing the head tags got rid of a request. Kind of suspicious. I didn't expect this either, and it turns out fixing the head tags uncovered another bug, which we'll look at later in the talk. Now, annoyingly, fixing the head tags made this site 139 milliseconds slower. Shit. I promised you I'm not going to massage the figures. This did get slower. And that's because your head is render blocking, right? I said the head is the biggest render blocking part of the page. Well, if you're ending your head tags halfway through, it's going to be faster, right? You make the head bigger, it's going to get slower. Even as a performance engineer, I would rather have this fixed and reliable than broken and fast, because then I can at least optimize the next stuff from a stable baseline. So yeah, there is, and if you buy me a beer later, I'll tell you why, because I'm really fucking boring about this stuff. There is a reason why there's only certain elements allowed. Do you know what I'm going to tell you now, because it's my time. Have you ever wondered why the link tag does so much? Rel equals style sheet, preload, prefetch, canonical. It's because we can't invent new elements to put in the head. We're not allowed. You can't put new tags in the head because it would break all old versions of browsers. That's why you hang everything off the link tag. Any new thing that goes in the head gets hung off the link element because that's allowed in the head. We'll just create new rel attributes forever. This is why you can't put new stuff in the head, and the link tag has to do so much. The optimum head order, this asterisk here is to remind me to tell you that this next one slide is basically the whole talk. When it came to writing this talk, I started with this next slide. I was like, it's a pretty good talk. Then I was like, oh shit, I need like at least 15 minutes either side of this slide. So get your phones ready. What we're going to look at is the optimum perfect head tag order. This is something I've been researching for several years now. And there is some contention. This is theoretical purity. This is theoretical perfect head tags. So when it comes to optimizing your site, what you'll find is you can't just, sorry, I should have probably put it on screen. What you're going to find is you can't just randomly, not randomly, but you can't just go in and reorder your head tags and everything works the exact same as before. This won't necessarily work immediately when you're refactoring, but basically this is the theoretical perfect head tag order. This is, again, a slightly shorter version of the talk, so I'm only going to discuss things that are in white. Anything that's grayed out is asynchronous, so kind of doesn't really matter where it goes. Anything that's asynchronous is a little less relevant, but I would still put them in this order. Again, if anybody wants to discuss it over a coffee, we can look at this slide and we can talk about the grayed out bits. Everything that's in white is either synchronous or annoying. I'm talking about your SEO meta tags. Meta tags are asynchronous, but I want to discuss that just to make sure any SEOs in the room feel comfortable about making these changes. So yeah, we're going to discuss the stuff that's in white. I'm going to bounce around a little bit now. The first thing, metadata about the page. I want to talk about a specific subset of that first, and then bubble up and talk about metadata in general. But that is basically your perfect head order, and we're going to find out why. So this was a really interesting one. Has anybody ever implemented a content security policy on a website? I can only put my hand up this far because it's very warm in here and I shouldn't have worn a pink shirt. Yeah, so you poor, poor people. Implementing CSP is a nightmare. Normally you would deploy it via an HTTP header, but you can, if needs be, deploy it via an HTML tag in the head, a meta tag. So it disables the preload scanner, and I'm just going to do a quick intro to what the preload scanner actually is. It was invented in IE8. IE8 actually called it the speculative preparser, because it's Microsoft and it's got to sound enterprisey. But basically, in the olden days, browsers were really, really slow. There was one parser that would do everything. That parser would be responsible for reading the HTML, discovering a resource, pausing while it downloads the resource, then runs the resource, and then can step to the next line. Find a file, pause, download it, run it. Everything was serialized, everything was very slow, and what it meant is specifically JavaScript files could not be downloaded in parallel. When there's only one parser that works synchronously, it led to a scenario where Waterfalls, Tetris, looks like this. That single parser would have to step through, parse some HTML, find a JavaScript file, download the file, run it, then move to the next line, and immediately it's like, oh, there's another JavaScript file. Got to do all that again. So very, very, very slow, very inefficient. IE8 invented something that we now call the preload scanner, which, when you think about Tetris, was very, very effective. This decoupled sort of parsing and execution from downloading. Download is now asynchronous. These files still run in serial, they still run in order. They're downloaded asynchronously, way, way faster. I've never managed to re-find the research paper, but it was estimated that this simple change made the web around 19% faster like that. Developers didn't need to do anything to take advantage of this. And ironically, developers often do things to undo this, which falls outside the remit of this talk. But the preload scanner is magical. It's a really powerful invention. And developers, we get it in every single browser for free. I was working on a client website, and this client was fascinating. They controlled thousands of websites. It's like a big blogging network that turns out it's all owned by the same parent company. And all of their sites, we're talking hundreds of properties, were really, 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 really slow. Can you see why? This client was convinced that their problem was with hosting. Blogs, like 25% of the web is WordPress. Nearly 90% of their blogs were WordPress, so they were convinced, if anyone's ever worked in the WordPress ecosystem, hosting is like the most important thing that people talk about. Dedicated WordPress hosting, blah, 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 hosting, hosting. So they spent a fortune, tens of thousands of euro a month, maxing out their hosting, and the site wasn't getting any faster. So finally, they emailed me. I took one look at this waterfall chart, and it's like, right, your problem isn't hosting. There's several reasons we know that. The biggest clue for me is that vertical green line around 9 seconds, that is your start render. That's the first paint. Look at how much is happening between 0 and that sort of 9.5 seconds. Very little of that is on the server. That's all JavaScript, it's third parties. If it happens before start render, it's your head tags. The head is render blocking. Anything that happens before start render has to be in the head tags. Just knowing that simple bit of knowledge means it was really easy to know where to look. Had to go look in the head of this site. What you'll notice here is lots of third parties. If you see these bits of like, it's the most ineffective pointer. If you look on lines like 11, 12, and 13, these are all different domains. These are third parties. So my suspicion was, okay, there's a lot of third-party stuff in the head tags. I'm going to rerun this test again, stripping out any third-party requests, and hopefully the problem goes away. Weirdly, the problem didn't go away. The problem became more obvious. Starting to look like this. And if we look at sort of line 11 through to line sort of 19, this very obvious stair, like it's like a set of stairs, right? This is how you lose at Tetris. This is not a good-looking graph. So I was looking at this and I was thinking, well, maybe each of these files is injected by the previous file. Like maybe that's why they're discovered one after the other. The reason that theory sort of falls down is injected JavaScript is by definition asynchronous, so you wouldn't get this stair step. And because it's asynchronous, it wouldn't actually affect all of this stuff here. This stuff would be free to download in parallel. So I could easily rule out that theory. This is not injected JavaScript. And then, because I'm really frickin' old, I was like, wait, this looks like IE7. The preload scanner was missing. Nothing was being downloaded in parallel. The preload scanner had gone missing. I had no idea why. I've never seen it turned off before. So then it became a very manual job to just line by line read this client's head tags until I found something weird. And what I did is, about halfway down the head tags, I found this. An HTTP equivalent meta tag. This basically allows you to define the equivalent HTTP header, but in HTML, halfway down the head. I removed this, reran the test, the problem went away. So I was like, that is weird. I got no idea why that would affect things. But of course, you can't just remove a content security policy. But at least it allowed me to narrow down the problem. I then went and read the preload scanner's source code on Chromium source code. And it said, don't preload anything if a CSP meta tag is found. I've never actually got to the bottom of why they disable the preload scanner. Obviously, it's a security thing. But basically, if they find a meta CSP in the head tags, they will disable a preload scanner. This is going to make things slow. A good friend of mine actually sat in the front row, a guy far smarter than me, Barry Pollard. I messaged him, I was like, hey Barry, can you do me a favor? Most of my friends only hear from me when I need favors. It's awful. Thanks, Barry. I was like, look, can you do me a favor? Can you find out how many pages, not websites, how many pages on the internet suffer this problem? So Barry wrote this query, and turns out it's very few pages. Desktop, 7,000, mobile, 8,500 pages. That's not origins, that's pages. That is correct, right? That's home pages. Oh, so it's, okay, maybe it is origins then. Weirdly enough, about 1,000 of those were my client, so. We couldn't remove the CSP, but what I did do is I just moved it to the top of the head. What I found really interesting is we got our parallelization back, so the graph got shorter, the Tetris sort of aspect. The graph got narrower, so it got faster. But we went from 11 requests down to just 8. What is really interesting about this is HTML is paused line by line. The preload scanner whizzes through the HTML, right? It starts downloading things. Then the main parser discovers a content security policy. Any file that was requested before the CSP was encountered gets discarded. The browser downloaded loads of files, then it was like, sugar, there was a CSP. It will discard those files and request them again with the relevant CSP sort of information. So we incurred a lot of double downloads. So by removing, or rather moving the CSP to the very top of the head tags, we got a lot faster because we got the preload scanner back, but also it meant every file that was requested was done with the correct policy. And my advice to the client was ideally deploy this as an HTTP header, but definitely just move it up to the top of the head. What was really interesting is this is such an esoteric, weird bit of behavior / functionality for me to discover. People aren't meant to know this unless you wrote the preload scanner. What happened is this client controlled hundreds of sites. And what they did in WordPress is they just created a custom field in the admin panel that just told their bloggers, would you like additional security, yes or no? Checkbox, oh, I'd love additional security. The developer in charge of implementing that feature just put an if statement in the middle of WP header.php or whatever it's called. Just said, if client wants extra security, put a CSP in here. And that. The hundreds of sites were slowed down drastically because of this simple, innocent feature. All we did is move that little if statement to the top of the head. This site got well, sites plural, hundreds of them, way faster. So moving the CSP made this one demo 3.7 seconds faster. How mad is that? So definitely, I mean, you probably aren't one of the 8,000 people doing this. If you ever implement CSP, just try and remember. You know when someone's been a developer for ages and they just know loads of real, like, annoying bullshit, and it's just like, you walk over to a colleague's machine and it's like, just move your CSP, and walk back to your machine just like, I'm sick of this job. This is one of those things you've got to remember forever now. So we're going to jump back up, bubble up a little bit, and talk a bit more about metadata in a meta sense. Metadata about the page that includes your CSP goes first. This double asterisk is to remind me to tell you, I'm not talking like Open Graph meta, I'm not talking SEO meta, I'm talking metadata about how the page should be dealt with, parsed, and rendered. Basically, as soon as you possibly can, which is first thing in the head tags, tell the browser how to deal with the page. I'm talking about your character encoding, your meta viewport, etc. In fact, the spec says that the character encoding of your page should go in the first 1,024 bytes of the document. That's 1,024 uncompressed bytes, because the browser only parses uncompressed data. So 1,024 is actually a big, like it's a lot of headroom, right? I would still recommend putting this really, really early, just so the browser parses the page with the correct character encoding immediately. The other thing is your meta viewport. Technically, because the meta viewport tag tells the browser how to render a page, and the head is render blocking, it doesn't really matter where in the head that meta viewport goes. As long as it goes before start render, the browser's always going to do the right thing. So none of you would do this, but let's have a look what would happen if we were to put our meta viewport at the closing body tag. The browser is rendering the page, and because it's parsed line by line, it eventually finds a meta viewport at the foot. What it does is it paints the entire page non-responsively, zoomed out. Then the very last thing it encounters before the closing body tag is the meta viewport that says, no, this should be responsive. So the entire page gets repainted. No one's ever going to do this, but you could write a trivial check to just say, make sure the meta viewport is at least inside the head. So metadata about the page should always go first. When we talk about the title tag, I would consider that metadata about the page. Here's a really interesting phenomenon here. On a desktop machine, where you've actually got tabs in the browser, on mobile you don't really have tabs that you can read. On a desktop machine, the title is often the first thing a user or a visitor will encounter. They see the title in the tab in the browser, then the page renders. Don't hide your title from the parser. If we had a simple snippet like this, I see line 3, we've got a slow script, and then the title on line 4. Because that script is synchronous, and HTML is parsed line by line, the browser doesn't even know there is a title tag until it's downloaded and executed that script. Therefore, if that script takes a few seconds, keep an eye on the tab in the browser Chrome on this video. So that looks broken. It's just a URL. And then finally, at the exact moment the H1 rendered, the tab in the browser rendered as well. I've seen third-party scripts that have timed out. It's taken 1.3 minutes for someone to see the title of a page. No one's going to wait around for 1.3 minutes. If you can get the title in front of someone's eyeballs immediately, at least they know, OK, the site hasn't rendered, but it has responded. If I just swap these two lines around, this site is just as slow. That script is just as slow, but the user experience is way better. Watch this again. At least we've got the title in front of somebody immediately, then the page can render afterwards. So try and avoid putting anything synchronous ahead of your title tag. All of these changes about metadata were non-file facing, like we didn't remove any files, we didn't make anything asynchronous. All we did is move metadata. Interestingly enough, therefore, the graph stays the exact same shape. Doesn't get any, like nothing moves around, we don't lose any requests. It's just as sort of the same shape as before. But weirdly enough, it was over 1/4 of a second faster. And if anyone's interested, like I did rigorous testing. For every single test I ran, every single change, I ran 5 tests, took the median of each one. So this isn't just like running a test until the numbers help me prove a point. This is fairly rigorously tested. Changing our metadata around at the median sped this site up by 1/4 of a second. OK, now we're getting to the fun stuff. Don't worry. The fun stuff is coming up. This is where it gets interesting. Put your synchronous JavaScript before your synchronous CSS. People hate this one. Whenever I tell developers this one, they're always like, no, that doesn't sound right, because CSS is render blocking, and surely your CSS goes first, because that's what we need to render the page. I'm writing an article at the moment. I started writing it yesterday, which talks about, like, honestly, I mean, I love CSS. My background is in CSS architecture. There's a way, way, way over-reliance on optimizing CSS and forgetting other things. So that article is going to be coming out in a couple of days, and a lot of it's to do with this. Synchronous JavaScript before CSS because, and most people don't know this, purely because no one told them, CSS blocks the execution of subsequent JavaScript. If you've got a CSS file before a JavaScript file, that JavaScript file will not run until the CSS is finished. Your CSS is blocking your JavaScript. The reason for that is a bit annoying. It's a defensive mechanism that maybe 1% of the time is the right thing to do. But the other 99% of the time, the browser will do this defensive move, and it will block your JavaScript from running. The reason is this. If this was asynchronous, if this style sheet could download while the JavaScript is running, we've got a race condition. That JavaScript is asking a CSS question. And if there's a race condition, the answer to get computed style could be stale. It could be correct if we win the race. It could be just incorrect. It could be out of date, whatever. It's a race condition. Because the JavaScript might ask a CSS question, the browser will halt the execution of any JavaScript until any in-flight CSS is finished. Then what it'll do is it'll recalc style the CSS. Then it can run the JavaScript and know that it could give the correct answer. The problem with this is a browser doesn't know what the JavaScript is doing until it's doing it. So if the JavaScript never asks a CSS question, it will still get blocked by the CSS. This is a bit of a trivial example. Where this becomes a little more realistic, a little more pertinent, is an example like this. All the time we get given these asynchronous snippets, usually for third parties. If you've seen these before, they're an anti-pattern, we don't like them, but third parties give us these snippets all the time. What's going to happen here is that style sheet will block the execution of that snippet. That third party is going to be late requested. So this reduced test case, you can see here, that JavaScript file doesn't get requested until the moment the CSS is finished. This is a very, very slow way of doing things. All we need to do is swap those two blocks around, and we're going to get complete parallelization now. We can now download the JavaScript in parallel with the CSS. What we have to do is identify, does the JavaScript ask a CSS question or not? And if not, put it before the style sheet. If you look at Google Tag Manager, their documentation actually tells you, place the script as close to the top of the head as you can. And most developers are like, piss off. I'm not doing that. I want my style sheets first. You're just here to collect data. They're not doing this to capture data. They're doing this to make the site faster. It's the right thing to do. So synchronous JavaScript before synchronous CSS. Except synchronous JavaScript blocks subsequent imports. This is a really weird behavior that I found. It's a bit of a regression in the CSS preload scanner. This is weird, but this is currently a bug. It's what I think is a bug. If you find it, it's a bug. If you're in charge of fixing it, it's a feature. And the Chrome team think it's a feature. I think it's a bug. So we've got some synchronous JavaScript, a blocking JavaScript file, defined just before a CSS file that imports another CSS file. Spoiler alert kind of thing is don't import CSS anyway. We'll come back to that in a second. But what we've got here is a paradigm in which some JavaScript is defined just before a style sheet, which will ultimately import another style sheet. The waterfall looks really strange. If we look at entry 1, that's the HTML. Entry 2 is the importer. What you would expect to see is the imported CSS to be straight after the importing CSS, right? You'd expect a CSS file, then a CSS file immediately after it. Weirdly, what we get is a CSS file, a JavaScript file, then the CSS file. It kind of looks to me like that CSS is coming out of the JavaScript. It isn't. This is a really weird behavior. I've got this massive delay which we wouldn't expect to see. When you stop and think about how browsers work, this actually makes sense. Browsers are single-threaded. They can do one thing at once, and that's going to be script, style, paint, whatever. If the browser's downloaded a style sheet, and it's also downloaded a JavaScript file before it, what it's going to do is, because that JavaScript file is synchronous, the browser is immediately giving a script task. So it'll do that script task, and what it will then do is it will then do a recalc style on the CSS. It can only do one of those things at once. Because the JavaScript was defined first, the browser basically has to run the JavaScript, it has to do the scripting task, before it can then look in the CSS and do a recalc style and see there is an @ import. What we're actually waiting for is the main thread to become available to do a recalc style. This is getting way too in the weeds. This does not need memorizing, because we can sidestep this completely. But what's happening here is browsers are single-threaded. We've given it a scripting task. In order to find the second CSS file, it needs to do a recalc style. It cannot do the recalc style until it's done the script, and the script in this case took quite a long time. Don't worry about memorizing that one. I'm going to show you how to sidestep it shortly. But to solve this problem, swap those two around, and the waterfall immediately looks like this. It's very rare we will get given @ import CSS. Usually it's third parties like Typekit. But if you've got a CSS file that @ imports something else, and you cannot get rid of that import, all you need to do is swap it so your JavaScript comes after that CSS file. I know you're probably all thinking, there's so many moving parts, how do I memorize any of this? The good news is you don't need to. I've got something for you coming up soon. A really good example of this is the Vans Canada website. Their head tag was enormous. There's was like 144 items in their head tag. You see that massive script on line 142? That was blocking. We had to wait until that script had finished. We had all these scripting tasks that were queued up before we were able to recalc style the file on line 100. Basically, on line 100, that file was meant to import another file, but we'd queued up so many scripts in between that it took 9.3 seconds before we could read the contents of line 100 to find out we needed line 144 anyway. Unfortunately, Vans Calendar isn't a client of mine. I ought to just, well, they've got quite a lot of problems in their head tags. This one specifically was delaying render by sort of 9 seconds. Well, not quite, because the JavaScript itself was delaying by 8.5, but whatever. So yeah, real big problem. I report this as a bug, and like I say, the Chrome team think it's a feature. We think it's a bug, so if you want to pile in and help me out, you can go and +1 that issue. Just by reordering my JavaScript and CSS into that kind of perfect order, we started to shove everything up, things getting tighter and tighter and tighter. That inline script on line 1 is now running immediately when the HTML arrives. It's not waiting for everything else in flight. We've managed to compress that import problem away. It's getting faster and faster and faster, so just reordering. I didn't refactor any JavaScript. I've still got an @import in my CSS. Just reordering these lines of HTML, we found another 1.65 seconds. @import is bad for performance anyway, and I'm still genuinely surprised it exists. Import in Sass is fine. Import in vanilla CSS, terrible for performance. Don't use it. Don't have time to explain why. You just have to trust me or read this. What I decided to do is kill off the import as well. And killing off the import, it basically brought that file completely parallelized. That was another 3/4 of a second, just by getting rid of one @import. So we're chipping away, and all of a sudden we've saved 6.6 seconds just by swapping a few lines around, getting rid of an import, getting rid of redirects. This is like, I start all projects by just obsessing with head tags. It's where a lot of the start render gains, nearly all of them, are set to be made. OK, this is just to keep your SEO team happy. SEO and social goes last. Stick it at the bottom. It's kind of Pascal's wager for web development. It doesn't really matter where your SEO stuff goes. So if it doesn't matter, stick it at the bottom. Basically, I get told this all the time. SEOs, I'm going to go back. You want a picture of that? Did you get a picture? Cool. Yeah, basically, I get a lot of SEOs tell me, no, I can't, if I put all my SEO stuff at the bottom, Google won't find it. Google won't index my site. You know, I don't want to put it at the bottom of the head tags. And this is when I get to tell SEOs that HTML is parsed. Some of you are still saying that with a question mark in your voice. Line by line? Right. HTML is parsed line by line. If Googlebot can't find the bottom of your head tags, your SEO team should be terrified, because it can't find the start of your body tags. If it can't find the start of your body tags, it can't find your content. HTML is parsed line by line. If you're worried about finding the bottom of your head tags, you should be triple worried about finding the start of your body tags, right? It's as simple as that. There are some minor exceptions. Googlebot can crawl the first 15 meg of content in an HTML file. Honestly, if your HTML file is bigger than 15 meg, SEO is the least of your worries. Some caveats there. This talk was basically co-authored by Barry Pollard, because he did some quick digging in response to some stuff I was talking about. In terms of, like, do you know when you tweet something or put it on LinkedIn, if you're feeling pretty corporate today, or you share it in WhatsApp or Slack and you get the image of the article you're sharing and maybe a description? Different social platforms do different things. So Twitter does a full GET request. It downloads the entire HTML. It will look through the entire HTML response for all your Open Graph, Twitter, meta tags, whatever they are. So it doesn't matter for Twitter how big your HTML is. It will grab all of it. The only interesting thing is Slack does a range request for the first 32 kilobytes. A range request is it's going to be 32 compressed kilobytes, so you're safe. WhatsApp does the first meg of compressed HTML. So really, honestly, genuinely, it does not matter where any of your social SEO meta stuff goes, unless you really care about optimizing for people putting your site in WhatsApp. And even then, you've got a 1 megabyte budget to play with. You're going to be fine. I've gone way over time, so I'm going to hurry up. I'm really sorry. The new order, like the new version of the head tags, is at this URL here. First contentful paint is now 2.6 seconds, so quite a bit faster than 9, or whatever it was before. We've made a huge, huge dent in this. We've made a huge change just by reordering things. It's simple changes. This is what the new head tags look like, and I'm keen to remind you that every single thing I've demonstrated today, I found on actual client websites. I haven't on purpose designed something outrageous or impossible. Every single one of these things I've fixed for someone before. Going back to the Tetris analogy, look how much healthier that waterfall looks now. The x-axis from left to right is how much time the whole thing took. It's now taking a lot less time. Yeah, whew, okay. To wrap up, and I promise you I am wrapping up, there's a lot to memorize here, and I don't expect you to memorize it. I have memorized it because this is what I do every single day at work. God, it sounds very boring when I say it out loud. I sort of wanted a way of sort of at least slightly automating this. Going back to a really awkward medical analogy, right? I started with the ancient Egyptians and stuff. I thought I was being very intellectual when I wrote this talk, and it's very transparent. It's very see-through that I am not. Computed tomography, right? You probably know it as a CT scan. I don't know if you've had one of these before. Regrettably, I've had a couple of these. First one when I was about 50 and I had an accident. These things are terrifying, but they're very good at taking a quick look inside your head, right? I had a head injury when I was a child. I had to go in one of these. CT scan, really good way at looking inside your head. See where this is going, can't you? Very, very clever. Just for fun, I made something called CT CSS. CT.css is a little bookmarklet, or you could install it with NPM, you could do whatever. Add it to your project, and it will highlight these inefficiencies in your head tags. I should not have written this in CSS. I did it for fun. It's not the right tool for the job at all. But just to have a bit of fun, I created this thing. This is the test page. And it will tell you things like, the async attribute is redundant on inline scripts. Don't do it. It's pointless. This file is blocking this file. Whatever, whatever. Green, and it's not very colorblind friendly, so if any accessibility folk want to contribute to this, please do. But green means this is fine, it's fast. Orange is maybe. Red is this is a problem. I don't know why I just explained traffic lights to you all, but that's what that means. If the file or the box is dotted, it means that this file isn't the problem, it's being affected by something else. If the lines are solid, it means this file is the problem, optimize this. So if it's dotted, it means something else is blocking this file. That was the test page for CT. CNN broke CT, which of course, CNN, right, for free, should have the fastest website on the internet, because everybody uses CNN as demos in their talks. Yeah, I guess they don't send people to conferences. If you want to use CT, it's right there. You can go and grab it. It's a bookmarklet. It's on GitHub, whatever. It's, I don't know. I use it on every project when I start performance optimization. I just click the bookmarklet, and it will tell me, cool, yeah, swap these two lines around, do this. That's blocking that. And it's a very quick, simple, not always 100% accurate. There are some false positives. But it's a quick, crude, and simple way of just sort of linting for all these. Do you know what? I just taken 47 minutes of your time, and I should have just said, oh, go and use that, and that's the whole talk. But with that said, I want to thank you for your time. That's been great. That's me done. Thank you very much. Okay. Do we have time for questions?
Just a question.
You're going to sit with me, right?
Yeah, we're going to sit very. So it's cozy, isn't it? It is cozy. So we are a little bit behind schedule, so 2 questions. Well, thank you for the talk, first of all.
You're welcome.
Very practical. You have no idea how many notes people were making. It's like it's out of control here. Thank you so much for everyone who's taking notes here and also online. 2 questions. One, oh, actually 3.
Do you
questions.
always sweat this much on stage? Wow. Yeah. Who asked that?
Yeah.
It's very warm in this room.
Favicons.
Favicons, ooh, interesting. Or is that just a question?
Yeah.
Favicons, stick those at the bottom as well. Interesting thing with your favicon is they're in the head, right? But you know your loading spinner when it's just spinning in the tab in Chrome specifically. If you've never visited the site before, that loading spinner is just a spinner. Then when your load event fires, the spinner stops, the browser requests your favicon, then it replaces the spinner with the icon. Subsequently, the browser is going to cache that favicon forever. If you ever tried cache busting a favicon, we know how difficult that is. Oh, I've got a really bad habit of giving really long answers to really short questions. At the bottom, favicons at the bottom with all the other stuff. They're asynchronous.
Cookie prompts.
Cookie prompts. Yeah, cookie prompts, it depends who you're using. A lot of them are blocking. Any third party you use, always try and use their asynchronous implementation. If they don't have an async implementation, it follows the same rule as everything before. If it's synchronous JavaScript, put it before your synchronous CSS. But as ever, just test everything. So as long as it functionally works, maybe you might need to move it before the CSS or whatever, but just test. The key thing is here, like the cookie prompt, the fact it's a cookie prompt is largely irrelevant. It's a third party, and it follows the same rules as all third parties. Yeah. Always try and use an asynchronous implementation. If they don't have an asynchronous implementation, use somebody else that does.
Right. Because the question is, do you request a cookie prompt script as early as possible?
Oh, 100%.
Or as late as possible?
As early as possible. Like, get that done, get it dealt with. One really annoying thing, if you're optimizing largest contentful paint, for example, you might have an image, which is the content someone's turning up for, and then your cookie banner arrives 5 seconds later, and your cookie banner's huge, and it's bigger than the image, and all of a sudden your LCP was a late-loaded cookie banner. Anything like that, just try get it down the wire as quickly as possible. So put it early, run it early. They're horrible. Kind of cookie banners make me feel like my job's pointless anyway. It's like, right, I've made your site faster, and now we've got cookie banners.
No, it's cookie banner. Yeah. Because
that's really made me miserable, man.
Yeah, just one more question. What?
It's a sad thing to talk about. Like, cookie banners are the bane of my life.
Yeah. So the last one, and I think that if you have any questions to Harry, you can also find him in the speaker area next to the book stand. This is a fun one. Ooh, somebody just deleted it. It was a really nice one. Hold on. Please don't delete questions in the Google Doc. That would be nice. But the question was, what has been the most shocking thing you've ever seen in the client's work, in a client's project?
Oh, wow. Honestly, nothing truly shocking I can think of.
Flash?
Oh, yeah, Flash. I worked with a client years ago who, on the audit, I just told them, I've managed to reduce your data overheads by 67%. Basically, they started a new project, and like any good developer, they just copied and pasted the head tags from the last project, and they were linking to a favicon that didn't exist. But they hadn't set up their response headers on the server. So instead of returning a 404, it returned a 200. They couldn't see any errors in their logs. But what they could see is, the favicon not working. Instead of reading the head tags to find out if they already had a favicon link, they just pasted a second favicon link into the HTML, which did work. It's a really long story. What was happening is the missing favicon was requesting a file that didn't exist. The file that didn't exist returned a 404 page, but with a 200 response. So they never noticed it. The 404 page, because it was a single-page app, the 404 page, after gzip, it weighed 1/4 megabyte because it was just full of JSON data. So they had one missing favicon. It was returning a non-cacheable 200 response. So as you went through their checkout, you lost 3.3 meg of data to a missing favicon. I deleted one line of HTML, and it was like the checkout process used like 5.2 meg of data. 3.6 of that was a missing favicon. So I deleted one line of HTML. And they frickin' loved me for that. It was great.
Excellent. Well,
that's not even a horror story. It's just weird things where it's like, you can see exactly how it happened, this perfect combination of stuff where it takes like someone as boring as me to find it. But yeah, they were like, oh my God, we saved 60% on our hosting bill. I was like, yeah, I'll take 30% of that.
Sounds good. So that means like we're going to go to McDonald's and do the cake.
I can't stand McDonald's, man. I don't know where that came. Out there, Vitaly was like, how do we...
Out of time. Okay, go.
We are absolutely not out of time.
Quickly.
He's like, how do we introduce? I was like, man, I'm boring. Like, there's nothing about me very interesting. So he said, I'll make up some things. You used to be a clown. You like McDonald's. I was like, go for it. And then he was like, how big's your apartment? I was like, I don't know. He was like, we'll use that.
That worked, right?
It worked.
Excellent. Oh, that makes me very happy. Have some really cool performance-related joke here. Do you want to share it, and then we're done?
I'm not reading your jokes. Oh, Barry, is that you?
You have to.
It's worded slightly wrong. I'm gonna reword it.
Yeah.
I would tell you a UDP joke, but you probably wouldn't get it. Those 4 people that laughed, avoid those people like the plague.
All right. Well, thank you so much, Harry, for being with us.
Cheers, man. Thank you. That was great.